Right, so for today's class, we'll be focusing on functions and error handling in Python. Okay, so it's a very important concept, a concept that we can't even avoid, right? Because basically, when it comes to code modularity, functions is where we usually run to. Okay, so we can't even run away from it. It's something that we have to do most often. Okay, so but in our previous classes, I think we've covered the data structures, we did conditionals, and we did loops. Right, so those are also important concepts in programming. So for today's class, we add functions and error handling, another two important concepts in programming, and then wrap it up for this week. Right. Okay, so as usual, we move from our slide to our VS Code, so we don't have to be switching between slides and VS Code, right? But this is the content for this class, right? So this is the content right there, introducing the functions, defining function, calling a function, function parameters, and the rest of them. So we will look at them one after the other, okay, in VS Code, right? So without wasting much time, let's navigate down to our VS Code. So quickly close this out. And as usual, all our source code lives in this folder called KodeCamp 5.0 codes. So I'll open up that folder in my VS Code, and we should have our existing files. So far we have 4 files here. So we add the feed file. So for each class, we create new files, and then we deliberate with that file, so we don't have to keep moving. All right, so I'll create a new file here, and I'll call for arrangement's sake, I'll start with 5. So this is well arranged, and then I'll call this functions. So I'll simply use func and then ampersand error underscore handling dot py. Okay. Right. So what exactly is function? Right. So what exactly is function? And most of us have heard of this. All right, and most of us have even used it in our previous. Most of us have even heard it in our previous classes. So we've heard of the print function, and we've heard of input function. So these are basically what built-in functions, and we've even heard of the typecasting function, the built-in data type functions like the int, the string, and the rest of them. That's a typical example of function. But what exactly, like, what do they do, or what are they used for? Right? What is the concept behind them? That's basically what we are going to dive in this particular class. So I will comment on this out, and then as usual put down some notes for a reference sake. Right? So a function, right? A function is basically a collection of code, a collection. So the thing there the keyword there is the collection of reusable. So another keyword there is the reusable. So I put this reusable in caps lock. So it's a collection of reusable code that perform a specific act. Right, so that's basically what a function is, right? So it's basically a collection of reusable code that performs a specific function, right? So in other words, it's a means of grouping source code and then reusing that source code without necessarily repeating that source code. I don't know if that makes sense, right? So it's a way of grouping source code, right? We group the source code, and then we then reuse that source code, right? We then reuse that source code without rewriting, okay? Without rewriting source code. So I don't know if that makes sense, right? So that's basically what function is used for, or that's what it does, right? So it helps us to do what, to group code, and then we reuse that code without necessarily rewriting that code all over again. So I'll give us a typical example. So let's assume that we have this instruction. So let's say we have the instruction of adding 2 numbers, right? It could be any number. So I would say probably I will have a num1, and then I would typecast this, and then put this an input, and then press and message say enter a number. I'll just repeat this again, and this will be num2, and then I will finally print out the result of so I have a new variable here called result, and then at the end of it all, this will basically be num1 plus num2. Okay, and then I'll finally do what prints this result. Right now, this could be what this can be a very a typical example of what of our instruction, right? And then if we execute this code, we know what happens. That will be prompted to do what, to enter two numbers, and then these two numbers is being added and the result is being printed. Right, a very simple instruction. Now, if this was the case, right, it would have been perfect. It would have been what, perfect, fine, without doing what, without the stress of going through what, doing functions and all those stuff. But then let's assume that within our source code, right, we have other existing code, probably a code that just maybe just randomly greet anyone. We could say hello, hello, code campus, rather. Maybe we could have another instruction that would say print how are you. And then probably after this other two instruction, right, we intend to use this function again, like this whole that complete set of instruction again, right? Now, without function, what would we actually do? We would actually need to do a come back here and copy that code and use it down. Oh, sorry, and use it down here, right? And you may actually be wondering, why not just put it inside loop? Why don't we just wrap this whole thing inside loop and it will do what? Do the same thing. But then, if that was the case, it would have been better. But then, we could actually just have probably just one more instruction left here, right? And this instruction can just say hi. And then we still want to do what, use that same code again. So you could see that the usage is not in order, right? We are using it when we want to use it and not necessarily what, repeatedly. So putting this in loop doesn't really solve that issue for us. Okay, so that is where function comes in, right? Where we do what, we can do what, group this code and then reuse it whenever we want to what, reuse it. That's the whole concept behind functions, right? That's the whole concept behind function. So now let's resolve this problem, right, using function. Let's resolve this whole problem of repeating instructions over and over again using what, function. All right, so in function, it involves two steps, right? When using function, right? When using functions, two steps are involved, right? Two steps are involved. Right? So the first step is that first of all, we need to do what, create, or we could say initialize the function itself, right? So the function needs to be what, available at some point, right? It's supposed to be stored somewhere, right? And then after this has been done, the second step now involves calling, or we could also say invoking a function. So that is two steps what that is involved. So you can create a function without calling the function, but you cannot call a function that is not what, created. So the function needs to be created first before it can be do what, be called or be invoked, right? And then if you do not actually invoke a function, it doesn't really execute. That is just the concept behind function. So it can be created and not being used, right? So the whole point of the usage is what, is this calling or invoking. And this creation here means that what, that source code, that grouping of source code does what, exists somewhere, right? So now the first step being the creation. So now how do we create functions in Python? All right, so to create function in Python, there's a keyword for that as well, and the keyword what is called def. Now when Python sees def, it knows, right? It knows that what, that you are about to do what, initialize or do what, create a function. right? It means a container that does what, that whole bunch of instructions that can be reused whenever we intend to reuse it. Okay, that is the whole point, right? So now what follows, or what it expects after that, this keyword is what is the function name. So because this is a keyword, we cannot do this, right? Because what def is understand what differently. So we cannot use def as a variable name, right? So once Python sees def, it expects the function name. So this function name here could be any name of your choice, followed by what, parentheses, right? And then within these parentheses, we can have what, we can have optional parameters, right? Parameters. So they are optional. Yeah, so they are optional. You can choose to have these parameters. You can choose not to have these parameters. And then after that, as usual, function works with everything works with indentation. So once I click on enter, it indents. So it means that everything that falls under that in indentation is considered what, as this function body. So this happens to be what, your function body. And the function body can be as long as, right? It doesn't necessarily need to be what, just one line of instruction. It can be as long as possible. And that is the syntax, or what, or the rules, right, of creating a function in Python. So remember, the def keyword followed by what, the function name followed by parentheses, and then within these parentheses you can have what, you can have optional parameters, which we'll come back and talk about. But for now, let's leave it as optional. Let's leave it optional, right? So we have that optional parameter, and then we can also have one important thing, optional return statement, which we also come back and talk about it. Optional return statement. We'll also come back and talk about it. So this makes a full function syntax, right? So now, having this syntax in mind, we'll come back and we'll solve the problem of code repetition, right? So if we come back again and we look at this code, now remember, you only want to use function if you have intentions of doing what, of reusing that instruction, that group of instructions. So if this was supposed to be one time, then there's absolutely no point why I want to do or put it in a function, because the whole concept of function is not being used there, right? So I just write it out once and leave it there. But since I'm reusing it and not necessarily in order whenever I want to use it, right? So that means function comes in and not loop, right? So loop doesn't fit in there that much, right? So having that syntax in mind, we know what we will create our function. So I'll go back and then I'll call this def, and I'll just call this any name. I'll just call this first function. Okay, first function. And then within this function, we have what, our parentheses, and then followed by what, optional parameter. But we'll leave it empty since it is optional. We'll come back to that. We will come back to that. Okay, so after that now is my function body. So since this is the instruction that and what I am repeating, you can see it here. I'm repeating that same instruction here again, same thing here again, and same thing is also being repeated here again, right? So it means that what I only want to do, what, have this one time and then do what, reuse it. So that I'll cut this man and put it as what, as our function body. So please, you do what, you indent it well, because at this point, this is what this is the only function body, right? So to make sure that all of them is a function body, I'll highlight them and then do what, tap them inside, right? So remember, tap is four spaces, so you can either tap or you can only use four spaces, but I always say use tap, because tap so that you don't end up having indentation problems. All right, so now we have our function there, we have our function created, but then we still have this other code existing somewhere. So I will simply just comment on this one out for now, right? I'll comment on them out for now, and then that's that, right? That is the whole concept of function. Now we can do what, we can execute our code, and as usual, nothing should happen inside our function, right? Because remember, I said about that in function, when using function, there are two steps involved, right? So the first step is the creation of that function. So and then I said that that we can create a function without doing what, using the function, but we cannot call a function without what, creating the function. So that means the function is created, but we haven't just used it, right? And by default, that is how Python behaves. If a function is created, it doesn't automatically execute the instructions within that function. So it will only execute it when you've called it or when you've invoked it. That's only when you do what, execute it. So because of that, and we have only these instructions coming up, because that is the only one that will follow the normal flow of execution by default. Okay, so so now, having that in mind, this is the step one of using function. Now the other step is what is the invocation, and how do we invoke, or how do we call a function? So it's simple. A function invocation. I'll put this function invocation. So to invoke a function is pretty simple, right? We simply do what, call the function by its name, followed by what, the parentheses. So I'll simply do what, call the function name, followed by what, parentheses. And then we also have what, optional argument, right? So it's optional because what we have, what, optional parameters. So if they were parameters, then an argument needed what to be provided. But then you may be wondering what's basically the difference between parameters and arguments. We will get to that, right? We will get to that real soon. So just know that if you had provided parameters during function creation, that you have to also do what, provide argument during function invocation. That is just the law, because by default Python thinks that if there is a parameter, that this parameter can be used within a function. So it makes it compulsory that when you invoke that function, you must do what, you must pass a value. The value can be of any data type. Now it's up to you as a programmer to do what, to manage, or to do what, or to program which particular or which set of what data type that you do what, that you intend to collect. But we get to that, right? We get to that soon. Right, so now let's go back again and let's see how we can start invoking these instructions without doing what, without necessarily rewriting this whole code all over again. All right, so now let's say that I intend to do what, to use this instruction, right, at this point, right? So now what do? I simply call the function name, which in this case is what, is first function, and then followed by what, my parentheses. So since there were no parameters, then I have no right to do what, to give any argument. So I leave it empty as it is, right? And then if I also intend to use that same instruction down here, right, where we commented this part out, then I don't have to do what, to rewrite this code again. All I have to do is to do what, is to invoke the function down there again, right? So I simply come here and put it there. Right, same thing happens if I also want that function to also execute down here. I simply do, I'll come here and do what, and invoke it there, right? So that means that if I should rerun this code again, I should have this set of instructions 3 times, but the code is only written 1 time. Okay, so let's go back and let's rerun again. Okay, so if I run again, I have what I have now. This entire number is the instruction coming from where, from within our function body, right? And it's the first instruction because outside this function, this is actually the first instruction, right? And which is what, invoking that function, meaning what, go ahead and do what, and execute all the instruction within that function. So since we have since the first instruction is what, is enter a first number, enter a number. So I can put in my 10 and put in my 20. I have 30, and then we have hello KodeCamp. So now it moves to the next instruction, and then how are you, and then you get to where you do what, where we invoke that function again. So what, it goes back again and do what, and execute all the code within that function one more time. So if I have my 30, I have my 40 in there, and then I have high, and then that high comes what, after invoking that function. We have high, and then we have that function being called again. So it means we'll go back and do one and call all the instruction within that function again. So I can put in my 50 here, put in my 60 here, and that is all, right? So now you can see that with the help of function, that we basically executed this code 3 times. We are doing what, without repeating, or without rewriting the whole instruction 3 places. Does that make sense? Does that make sense? Do you have a question? 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 All right, so the silence means no question, that we are actually on the fully. All right, so that makes sense, right? That's the whole concept, right? That's the whole concept about functions. That is the whole concept about function, a grouping of code and doing what, and reusing that code without necessarily rewriting the entire code over and over again. So if this was to be used one time, then there's no point of being what of rewriting it or putting it in function, right? Just put it at once and then leave it there. Okay. So, but then if you have intentions of reusing that code when over and over and over again, then please, function is what you should do. What is what you should always go for. The function is what you should always go for. Right. So now having this in mind, right? So now having this in mind, let's look at what function parameter. Now let's go back and let's look at what that optional parameters, right? This part that we left out, the optional parameters. So what exactly, first of all, let's understand what exactly is function parameter and what is function argument, because people tend to conflict these two things. There are two different things, right? There are two different things. Difference between, okay, so difference between function parameter and function arguments. Right. So what exactly is the parameter and what exactly is argument? So parameters are more like are more like placeholders or the actual values. Right. Right. So now let's say that that we come into this call, right? And I wasn't available to take us on this course, right? Probably I had a small challenge that requires small that will take about 10 minutes of my time. And then let's assume also that the project manager comes in and then try to do what and try to take us on this concept, right, of functions. Now at that point, the project manager is what is a function parameter, right? It's more like a standing in what for the actual tutor, right, to come in and take the course, right? So that's basically what parameters are. They're like placeholders, right? Waiting for the actual value to come into the function, right? Now while the argument itself, right? Now what argument is the actual value, right? Is the actual value. Right. So now when we invoke this function and then we pass in that actual value, and that actual value is what is the argument, and then this parameter what is the placeholder that will receive that actual value. Does that make sense? Does that make sense? Right. So silence means that actually made a lot of sense. Okay. So now, what is the purpose or what is the usefulness of these function parameters, or what is the usefulness or yes, what is the usefulness of function parameters? So please confirm that you guys can hear me. I think someone is having difficulty hearing.
Can hear you, sir.
Can hear you too.
Right. So I don't know, Mr. Victor, please. I think it's from your end. All right. So what is the function or what is the usefulness rather of these function parameters? All right. So and like I said, they are placeholders for actual value. So it's a way of doing of sending value from external from outside your function body to inside your function body, right? Now let's assume that that you have multiple functions, right? Let's assume that I have another function here. Let's say a function called multiplication, right? Multiplication, for instance. Okay, and this function, maybe this function is to do something, right? Maybe this function is to multiply two numbers, right? I'll just copy this man. Right? And just put it there. And then at the end of it all, this function will do what is will send out a result. And then we want to do what we want to pass this value, right? We want to pass that value to our function, right? Now, you have to send value from outside your function to inside your function. You simply use what the parameter. Okay, so to resolve that problem, let's assume that okay, let's assume that this multiplication here, okay, is going to do what? Is going to multiply two numbers, right? And for now, we don't really know that two numbers, okay? So I'll just simply say num1, and I'll assume that those values should be identified as num1 and num2, right? So I'll simply say let result be num1 times num2. right? And then I'll do what I say print print result, right? But then at this point, num1 and num2 is not known yet, right? It's not known, but I am assuming, or I am saying that those that were that this function will take two values, right? These two values can be any value at all, right? But then I'm also considering that what are those values that will come in are going to what numerical values, and I want to identify them as what as num1 and num2, and then simply multiply these two numbers, right? So what I can do is to go to my function and provide these names, or how do I want to identify this value, right? So in this case, I want to identify them as what as num1 and num2, right? So you can have more than one parameter, right? So in a case where you have more than one parameter, then you do what you separate them with comma. So in this case, I'm saying that this function will take in what num1 and num2, okay? And then I'll simply multiply num1 and num2. So at this point, I don't know yet what num1 and num2 will be, but I'm also doing hoping that whatever value is coming in should be numerical values, and it should be two of them, right? It should be two of them, one as num1, the other one as num2. Okay, so after doing that, it means that whenever I intend to do to invoke this function they call multiplication, I have to do I have to provide two values, where the first value will be seen as as num2, and the second value will be seen as where the first value will be seen as num1, and the second value will be seen as num2, right? So if I go back again, I'll just comment on all these ones out for now, right? So it doesn't come in and confuse us, right? So and then shift them down, and then up here I'll do what I'll simply call on multiplication, right? On multiplication, and then I put in my parentheses. Now, if I try to execute this code, this will give me an error saying that this function called multiplication is missing two required positional arguments. All right. So the argument is two required positional values, where the first position is num1, and the other position is num2, or is seen as num2. Okay. So it means that I have to come back here and provide two values. So at this point, we haven't actually written the logic that this value must be number. So at this point, we can put any kind of type. So I can come here and put hello, right? And come here and put hi, and nothing will still happen, right? Nothing, it will still execute just fine, right? So the whole thing is that Python wants to do what? Python wants you to put two values, right? Python wants you to put two values. Now, how values is used within this function body is up to what the developer. Okay. So at this point, if I try to execute this function, of course, this will do what? This will throw an error. Okay, because we are trying to do to multiply string with string. But then within my function, I can come here and put some conditional statement and saying that the type must be integer and the rest of them. Okay, but then I wouldn't want to go through all those stress. But you guys can actually do that, because I'm sure that you guys are capable of doing that. Right. So if I run that again, then this throw an error as expected, right? I will assume that the user is a very good user, that, of course, that knows that you should put in actual numbers and not strings. Okay, so if I put in my 10, I put in my 2 here, then this will give me 20 as the result. So I have 20 there, right? So what basically happened is that this values was passed was replaced by these actual placeholders, right? And then this value here is being used within this function body, right? And then this calculation was carried out, and the result is being printed. That's basically the purpose of parameters, right? So they are basically used to do to send in values from outside our function body to inside our function body. But then you may also be asking other questions like, why don't we? So what if we just have something like this, where num1, right? Where num1 is equals to, let's say, 10, and num2 equals to what? Num2 equals to 20, or 2 rather. Okay, and then I simply come in here and just do result equals num1 and num2. Wouldn't it work? Of course, this will work. So I can come here and clean this man out, because at this point, this man no longer doing what expecting any parameter, right? So I have to take that one out. Of course, this will work, right? This will do what? This will execute just fine, right? This will execute just fine. So if I should execute this now, I'll have what? I'll have 20, right? But there's what there is a downside. There's a downside to these things, right? So it is there's a reason why parameters are more recommended than doing this, right? Now let's assume that I intend to invoke this same function again, right? But this time around, I want to invoke this function with what? With another variable, with another value. Let's say 50 and 30, right? But then what happens is that I have to come back and do what and change 50 here and change this man to what? To 50, and then and change this other man to what? To 30, right? But then the problem here is that this value now will do what? Will now cut across both this other invocation and this other invocation, right? So to have value works, what it works globally. It works for all the functions that uses it, right? So that makes this variable what? A global variable, right? That makes this variable what? A global variable. So it means that if I should invoke this function multiple times, that other function will do what? Will use the same value, right? We use the same value as what of 50 and 30. So if I should run this now, you see I have the same value two places, 1,500, 1,500, right? And this violates the whole concept of what? Of functions and parameter, because the way function and parameter works is that each invocation can carry its own separate value, right? Without necessarily conflicting another what? Invocation. So it means that the function can be used with multiple different parameters, right? Without necessarily conflicting or other invocations, right? So let's assume that probably that this was supposed to be a okay. Let's assume that this function was supposed to do what? To calculate um to multiply someone age by 10. So it means that if I invoke this function for the first user, right, that the first user age now can be, let's say, 20, and probably I'm doing 20. I'm multiplying their age by 2. So that means this first user should be like 40 years, right? If multiplied by 2. And then this second user, if this man here is 10, then that means his age should be 20. But from the way we are doing, from the way we are referencing these values, it makes it difficult to do what to accomplish that, right? So it means that all the users will have the same ages. Okay. So that is why what parameters is more preferred than doing this, right? So to solve this problem, I can do what I can come back here and bring in my num1, right? I'm putting what my parameters num1 and num2, right? And then of course, if I should invoke this now, it will this num1 and num2 will simply assume that we are using what this variable called num1 and num2 as what are the values there, right? But then it can also mean that I can explicitly come here and pass in my own separate value 20, 30, and come here and put in another value called 10, 2. And each of them will fire up differently for different values. So if I should execute this now, I should have different value for each of them. So I have 600, I have 20. So each function existing on its own, working with its own separate value. So that's the whole point of the word of parameters, right? It helps you bring in it helps you bring in what values into your function, and also makes that function to be more like what a standalone function that can operate with its own what separate value. Do we understand? We understand. Should I
Yeah.
should I go about again? All right. So the silence means that we completely understood. All right. So, but then there's also one more thing about function, right? So function also have what we call variable scoping, right? So function have what we call variable scoping, right? So basically, what this thing here means is that variable that is defined within a function is not accessible outside of the function. That's basically what it means, right? Variables within this function cannot be accessed outside of that function. So take for instance, we have this variable called result, right? Inside the multiplication function, right? If I come outside this function, right, and I try to print result, let's say print result, right? You see that what that already I'm having a warning sign. It means that what that we cannot see results, right? The result is nowhere to be found. Right? Result is no way to be found. So if I run this again, you see that what that we say that what result is not defined. But then we have results. We have see results here. See results there, right? So please just note that what that variable that we define inside a function is local to that function. It means that it lives and it will die inside that function, right? Outside that function, it does not exist, right? But then variable that is defined outside a function is known as global variable. And these variables can be accessed both outside of function and inside of what of function. So these variables can be what can be accessed can be accessed both inside and outside of function. That's why when we took out these parameters, we can still what use these variables as it is, right? Because that means those variables are what are global. So that is why we could use them. But then we can't reference this result. We can't reference this result outside of functions, right? So they are local. Please note that and put that in mind. Okay, so the one more concept about function, and we wrap it up with function, is that when we invoke a function, right? When we invoke a function that has parameter that we explicitly need to specify the values based on the arrangement of the parameters, right? So what do I mean? Let's assume that this first function here will take in two parameters, right? Called name and what and age, right? So it means that if I invoke this first function, right, that in all I do, right, that my first value must be name, right? My first value must be name, because assuming I am using this, let me take this out. Assuming I am using these variables to maybe to print something like, let's say hello, name, right? Then I now say you are so and so years old, right? Right. So and then probably this is what I'm using what these parameters to do. So it means that if I invoke this function, in all I do, my first parameter must be name, and my second one must be age, right? So in that case, if I come here and I put Savior as my name, assuming, and then I put, let's say, like 100 as age, okay? And then if I invoke this, then of course it will work as we expect. Hello Savior, you are 100 years old. But for any reason, maybe for some obvious reason, right? I mistakenly conflict this and put in age first and bring a name second. Then what there is problem. At that point, I'm now seeing what hello 100, you are Savior years, or you see you see the confusion, right? So that is one thing about what argument, right? So by default, this kind of arrangement is known as positional argument. Barry, your hand is up. You have a question?
Good morning, everyone.
Good
Morning, sir.
morning.
Okay, so since this dev is like this function is not going to show, so how is the user going to know that the user is supposed to input his name and age first?
All right. Fantastic question. Okay, so the whole point is that the whole point of the function is for you developers, right? Not to rewrite code multiple times, right? And then you as a developer, you know how you arrange your parameters. But then for some reason it might skip your head, might skip your mind that this function should take in name first and take in age, right? So you as a developer, you are responsible for arranging these values in the way it should be for your function, right? That's your job as a developer. The user has absolutely no idea of what function is. If you go and tell client, so you put parameter in this function, they will look at you first. First of all, they'll ask you what's the parameter, and then ask you what is what function. So it is you now as the dev that knows, right? This function is taking how many parameters? Probably three. And this is the arrangement. But then at some point you may forget it, because if you have multiple, if you're working on a larger project, right, and you have multiple files, and this function needs to go in from one file to another file to another, and at times you may actually forget, right? That name should come first before age. And then if you forget, there is problem, right? Your code start behaving in ways that you can't even that you can't even understand, and it becomes difficult to start to find where the error is coming from, because what this function is going into what multiple files. Okay, so it is not the client's or should I say the end user's role to know what values or how to arrange those values. It is your job as developers, right, to know which value comes first and which value comes last, right? You understand?
Okay, sir.
All right. So yeah, Mr. Usher, your hand is up. Is it Usher? Yeah. User rather. Mr. User, your hand is up. Your hand is up. We can't hear you if you're talking.
Hey, hello, can you hear me?
Yeah, I can hear you now. I can hear you. Okay.
I wanted to ask initially, when we defined the function multiplication and we used the global function, global variable, num1 and num2.
Okay.
When you called that
Okay.
function the second time,
Okay.
when you input the values for the multiplication num1 and num2, the global function was override. Like the result for the global variable was not given. So I wanted to know why it was not given. It was override. Can you hear me, sir?
Well, it's pretty difficult to hear you properly. Okay, but right. So if I get your question properly, right? So you said that when we used this multiplication function where we were referencing this
Yes.
global value, right?
Very-
And
mm,
then I said that if we invoke this function, let's say multiplication, without explicitly putting this value, right? That it use the global variable, right? And then the
When we
other
when
time
we
I'm
when we
coming
put
in.
the
Okay. So when we inserted this 20 and 30, it override the global one, right? Is that what you mean?
yes, yes, that's one. Yes,
Oh, okay. All right. So let me explain again what really happened there, right? So, right. So the thing is that you know what that Python will execute your code from the first line all the way to the last line. Okay. So the very first line of instruction in this code is this point where we have this, right, where we have num1 and num2. That's the very first execution where we have like that's where our code is starting from. Okay, and then after that, excuse me, after that we now have a a function whose placeholder matches that variable name called num1 and num2, right? So at that point, when we invoke, right, when we invoke this function, since we already have a variable num1 and num2, unfortunately, this variable matches the names of that placeholder. So Python automatically assume that these are the values of what of num1 and num2, right? So it assumes that we simply declare a variable called num1 and num2, and then we pass it as placeholder to what to this function here called multiplication. So it will assume that's the value it wants to use at that point. But then, because these are what num1 and num2, it means that the values can be changed, right? So now we now said that you can as well explicitly do was come here and type in your value, right? And it will override it. Okay. So remember, place order are not like fixed values, right? They're like um, parameters are not like fixed value, right? They are like placeholders for the actual value. So it means that its value can be overwritten, it can be changed, right? So at this point, num1 is no longer referencing this man here. Num1 what is actual what is 10, the actual value that we've provided, and num2 is what is 20, the actual value that we've provided. Does that make sense?
Yes, sir.
All right. Is any other question? Any other
Yes,
question?
sir.
Any other
Yes, I have a question.
Okay, shoot. Go ahead and ask a question.
With this multiplication, can you hear me?
Yeah, I can hear you now.
Hello?
Yeah, I can hear you now. I can hear
I
you
said,
now.
I said, will the multiplication run without you putting anything in the argument as the
Yes.
argument?
Yeah, it will execute without putting anything, right? Because of because it will assume that these are the values that should be used as num1 and num2, right? So it will execute without the argument. All right, so is that understood?
Please, sir, can you run it?
Okay, all right. So let's do that. All right, so I'll comment on this out. Yeah, okay, let's execute. Okay, let us see what is happening. All right, it says that num2 and num2. Okay, let's see.
I think it's not properly indexed.
Yeah. Oh, sorry,
Because
sorry.
I'm thinking that we have to put it inside
Yeah,
the
you have to
bracket.
explicitly put that num1, right? You have to explicitly put num1, comma num2. Yeah, so that will be the case. So you fix in num1 and num2, and that will be the case.
Okay, thank you.
Yes. All right. Let's can we proceed? I think I saw Mary Jane's hand up.
I've asked. I was not the asked
Okay,
question.
okay. All right. So that is the case, right? But then yes, yeah. I totally forgot. So that wasn't what we did that led to this number one number two. Okay. So I think previously, what we did, we said that if we take this man out, right, and reference variables outside a global variable, right, within the function, right, that this will work. And then that way we don't have to specify this man again. So it means that every time we invoke this function, then it uses this global variable thing. That's what we did before we then came back and fixed that number one and two. So the moment you provide parameters during your function creation, you must provide those values during function invocation. Okay, that was how we arrived there. All right. Any other question before we proceed? Any other question before we proceed? Okay. So all right. So let's go ahead. Let's proceed. Okay. So apart from the all right. So let's proceed. Let's proceed. Okay, so one more thing again, one more thing about function is that functions can also be variable. Sorry, can also be variable values. Okay, what do I mean? I mean that that I can take for instance this multiplication. I can assign this to a variable, say hello, or I say a, right, and then this happens, right? I can do this, right? Functions can be values for a variable, right? Please know that your function can be a value for a variable. So what happens is that if you do this, right? If you do this, okay, it means that you're simply saying, please, this function execute to, right? After executing, assign your result of your assign the end product of your execution to the variable called a, right? That's basically what it means. It means what? Execute and do what? Assign your end product as the result to what? To as a value to what? To the variable called a. And at this point in time, this function does not have any end product, right? This function by default, your function does not have any end product, right? So as such, its value is none. So if I should execute this code, right, I should have the instructions within this function execute, but then there is no value was what was returned or was being assigned to the variable called a. Okay, Miss Blessing, you on it? You have a question?
One, I have a question. Is it possible to put a loop inside a div function?
Yes, all the concepts that we've learned so far are concepts that can work within themselves, right? So those
Okay.
concepts is for you to know when to use them and use it appropriately. Okay.
Okay.
Yeah. So it doesn't mean that they're standalone. It's meant for all of them to work together. Okay. So they can be loop inside function. They can be function inside loop. They can be loop inside conditional inside loop inside function and so on and so forth. Right. Just mix them up as far as you understand what is happening behind the scene. Right? So all this concept is meant to be used together. Okay, so back to what to function as a value, right? So so I said that your function can be what a value for a variable. So, okay, so someone has a question before we proceed.
Okay, does it mean that if you assign the function call, if you assign it to a variable, so if you want to use it, you are just to um use the variable, right?
Exactly. Yes. Yes. That's the whole concept of function as a value, right? So it means that we can invoke this function and assign it to a variable. So what it then means is that this function should do what should fire up and then send out an output, right? There should be like an end product of this function, right? We are assuming that there should be an end product of this function. So it means that I can, if I want to, I can do what I can simply come and say print A, and I should do what I should get the end product of that function. If the end product was high, I should get what I should have high. If the end product was um hello, I should have what I should have hello. If the end product was 10, I should have 10. If it was a list, I should have a list. If it was a dictionary, I should have a dictionary, right? Whatever the end product is, right? I should be able to do what get that end product from a variable called A. But then, like I said, this function or all the functions that we've created so far does not have any end product. And by default, if your function does not have any end product, it gives none. So it means that if I should print A now, I should have none as the end product because this function, all of them, do not have any end product. Okay, so if I should fire this up, I have 1,500. I also have none. Now, and the 1,500 is coming because inside the multiplication function, we do what we printed it, right? So basically, if you have a print statement within that function, of course it will print, okay. But then it doesn't mean that is the end product of that function because this is the end product of this function. So if I comment on this print out within our function, right, and then execute again, then I should have what I should have none. So none is what is the actual value of that function. It means that this function did not return any or did not have any input. There was no final product from this function, right? So now how do we now make our function to have a final product or to have an end product, to also have a final value, right? That is where the optional return statement comes in. So you can say what it's optional, right? So you use it when you want to set out what an end product, right? So only use the return statement when you intend to do what to send out an end product, right? So that is when you use what the return statement. So apart from that, then you don't really need it, right? So if a function is just to fire up and do something and then end, then nothing should really happen. Then you don't need the return statement. But then if a function should fire up and then do something and then at the end of it, or you're expecting a result from that function, then that result can be sent out from the function using what the return keyword. Now see the difference. The parameter takes in values, the return statement takes out value. Okay, so now that's the difference between what the parameter and the return. The return sent out, the parameter takes in. Okay, so now if I should now go back again to our multiplication and function, and then I simply say return, and then after the return keyword, what do you want to send out, or what should be the end product of this function? If I should simply come and just say hi, it means that what the high is the end product. It means that if I should fire up this function, what I will have is high as the result or as the end product of this function, right? So if I should run this now, I have high. So high what is the end product of that function. But at times, in actual sense, in what the end product should be like the final result of your function what execution, right? So if this is my function called multiplication that multiplied two things, right? So it means that like the final product should be what should be that result, but so I will simply just come in here and change this to what to return of what of result. So this result now becomes what my end product. Okay. So now if I should now run again, I should now have what? I should now have 1,500 as a value and not the other one that we had as a printed something, right? Because the other one was printed. This one here is what is actual value. So it means that what? It means that I can still come here and do something like this plus 10,000 and it do what? And it work. Because, right? And it was, so it means that what? Multiply this thing and then carry that end product and do what? Add 1,000 to that end product and that should be my A. So if I should run this now, of course, you can see that happens. Okay, it added 1,000. So that return gives an actual value, right? An actual value that we can play with. Okay, right. So people hands are up. So let's start with I think some people hand. Mary Jane, your hand is up.
Okay, can you hear me?
Yeah, I can hear you now.
Okay, does it mean that return does the same work as print?
Return does not do the same work as print. Print simply just display to end user, right? That's what print does. It displays to end user. That's basically what
When
print
you use
is.
return, it's also displayed.
So return doesn't really display. It's displayed because I printed it. So if I not print it, then nothing would show. So you see, nothing show. But behind the scene, the value of our A here is what is the result from our function plus 1,000. That's basically our result. The value of A, right? Yes. So
okay, so it's safe to say that you use return when you want to use the answer from the function inside another
exactly,
place.
exactly.
Okay.
Exactly. That's the whole point, right? So you use return when you intend to use that answer some other place within your code, right? So you use the return statement. Apart from that, by default, your function will do what we return none. All right. Any other question? Okay. So Mr. Gabriel is saying that he doesn't really understand. Mr. Gabriel, please can you unmute and point out where we can explain it again so that you can understand better.
Good morning, bro.
All right. Good morning, sir.
The place I'm not getting is this return now, and how to use it. I don't really get it. And you said I can only use it when you are using it in another code or something. Please, can you explain?
Oh, okay. So let me reiterate that. Let me re-explain that for us. Okay. So the whole purpose of return is to send out value from your function. That is the whole purpose of return, right? So take out this return from your function. Your function only executes without having it, like without sending out any value, right? So it means that this man will do what will collect two numbers, right? And then multiply those two numbers and then save that number what in a variable called what result. But that result will do what will live and die in your function. Outside your function, we cannot get this result. Remember, okay, let's assume that I want to use this function, right? And then to multiply things, and then at the end of it all, I want to get that result. But you see, I cannot come and say, okay, I cannot come to my A and say, okay, let the result, right? Let the result now, okay? The result now being what? Being this result plus, let's say, probably I wanted to add, let's say, 20 to that result. But you see, I cannot get that result because that result is inside a function. And I said about that variables or values or basically variables inside a function cannot be accessed outside a function, right? So there is no means of us getting the result from that function, right? So it means that, of course, the function works, it multiplied, but then that value of that multiplication lives and dies inside your function. You can't get it, right? It's similar to doing this. It's similar to doing input, right? Without assigning it to a variable. It means that whatever user types will live and die during your code execution. You can't use it inside your code, right? That's basically what it means. So same thing is happening there. So let's assume that I assign this again to a variable called A, and I call this multiplication, right? Okay, let's close it down. I call this multiplication, and then I provide my values. Let's say I provide my values 10 and 10. Okay. And then I'm hoping that I need the result of this multiplication somehow, so that I can use that result and probably have another variable called final result, where I can use that result from A, right, and probably add it to something, and probably add it to maybe add 50 to it, or something like that, or let's say 100, right? And then at the end of it all, I want to print final result, final result, final result. Okay. And then if I should fire this up, this should throw an error. This line here should do what? Should throw an error for us as expected, right? So the error says about that we are trying to do what? An unsupported operation by adding what? A non-type to an integer. So it means that what one value in this thing is integer, the other value what is none. So it's very obvious that this is the integer value, and this other one what is the non-value. So it means that nothing was sent out from the function, right? Nothing left that function and came out, right? So things only went inside, but nothing came out. That's basically what function does, right? So if you use a function with parameter, it means it takes things, but nothing what is coming out. And most times that may be the case, but most times, of course, something should actually do what? Come out, right? Okay, assuming now that let's assume that you will use one of the built-in function. Let's assume we use one of the built-in function, like let's say print. So if I type in the print and then type in what should show, but then nothing shows, right? Nothing came out of that function. Like there was no result. Nothing came out. That's basically what it does, right? That's basically what it means without a return statement. The function works just fine, right? But nothing left that function to our external code. Nothing left that function. Everything was processed and everything died inside that function, right? So the return statement now comes in if and only if you intend to want to send out something, right? So basically, what happens is that when Python gets to this return statement, it does what? It looks for the value beside it, and be like, okay, this is what is leaving this function at the end of it all, right? So in this case, if I now say, okay, return something like hi, right? It means that what? That this function will take in two variables, two arguments, right? Num1 and num2, and then at the end of the execution, hi is the only thing that is leaving this function, right? So it means that if I should assign it to a variable, I am expecting what? Hi as the result, or as the value coming out from that function, right? So now if I should try to add this again, I should not have another problem saying what integer and string kind of what operation, right? So you say that we cannot concatenate what a string with integer. So the problem is that one thing is string and the other thing what is integer, which is what and this is the integer and this is what the string. Now this string is what is high. Because high is the value that is being sent out from that function. Do you understand? Did that make sense, or did I even went and complicate things for you? Are you with us?
I don't know. Just continue, let's.
Maybe Jane, Johan is up.
Sir, please, can I just request that you do something on your screen, please? Can you uncomment the print result under multiplication function?
Okay,
Then
okay.
yes,
So uncomment this, okay?
yes,
Right.
then comment
The return. Okay, I'll comment the
yes.
return. All right, let's comment return.
Okay, then can you like print A after you called it? Like
Okay,
under it, can you print?
oh, okay. All right.
Okay, can we see the results? Like
Right, so the result would be the value of the multiplication and then none. Right. So let me comment on this other one. So these other people are causing errors. Right. So we have 100, we have none. Right. So let me tell you what is happening there. right? So this 100 is coming from our print. So you're simply saying that, so when we invoke this function, right? Of course, this function will execute all the code within itself, right? So it takes what? It takes 10 and 10, right? And then inside itself, it says what? It says the result should be equals to what? To 10 times what? 10. And then inside itself again, it says what? Prints that result. So basically, this is what? This is the print statement. And then at the end of it all, okay, that is the end of what? Of the function, right? That ends the function. That's the only instruction for that function, right? But then we are still having none. And this none here is coming as what? As, remember I said that what? That if your function is not sending out something, that by default it sends out none. So it means that that nothing came out from that function. So this is like the value of that function, none. It means that function did not return any value. Nothing left that function, right? So even if I try to carry out this math again, even if I try to carry out this math again, it will tell me that what? That we cannot add none with integer, right? So you still have what? You still have non-type and integer kind of problem. So we can't add non-type and integer. So this is the integer, this is the non-type. So the value of that function is none, meaning that what? That nothing left that function, right? So there was no return statement in that function. So as such, the default value becomes what? None. So return statement is used to do what? To send value out of your function, because what? Your function deals with things locally. It means that everything that is within itself cannot be accessed outside. So the only time you can send something outside that can be accessed outside is what? Is with the return keyword. Does that make sense?
Okay, can you now uncomment the return statement?
Okay. Right. So we should still have
No, like
another.
it will be result, like it will be result now instead of the high.
Okay.
Like return result. Yeah.
Right. So this should work just perfect. Right. So let me close up and let's run this again. So you see, we have 100, 100. Now 100 is, one of them is print, the other one is the actual 100 value. So one of them is this point where we printed the result, which is this first instruction here, and this other one is where we printed the value that is sent back from that result, from that function, which is what? 100.
Okay, thank you, Gabriel. I don't know if you understand now. If it helps.
I don't really understand. I want to ask something here. That
Okay.
A is equals to multiplication 10. Can you do it in a way that you will just call the return instead of typing out the multiplication bracket 10 10? Like A is equals to, you place the return as a result.
You mean, okay, here?
Yes, something like that.
Like return as result here?
Yes.
Right. So the thing is that this return is also a special keyword that must live and die inside a function. So if you take out this result outside a function, it does not it gives you error. Same thing with break and continue that lives inside loops. Return must live inside a function. All right. So we can't come out and then use it outside of a function, right? It returns error.
Okay, that means what we will write is the main function. That is the def function.
Exactly. Yes. So
that's
exactly.
def first function.
Exactly, something like multiplication, okay? And then since this man takes two things, we will like 10, 10, right? And then we now use inside the function that we can now return, right? That value, right? So this takes in things, this takes out things.
I think another thing that's confusing him is assigning the function call to a value. One of the things that is confusing Mr. Gabriel.
Is that what is confusing you? Remember,
that one follow too, Sha.
Okay, okay. So remember, I said that function can still be used as value, right? In order for a function to be used as value, it means that it can be invoked and assigned to a variable. Okay, so you don't have to do this if your if you don't want to use your function as value, you don't have to do this, right? But then trust me, 98% of the time your function will always be a value. I'm telling you the truth. 98% of the time, your function will always be evaluate. Now, a typical example again could be that your function could use another function, right, as value. Yes. I can have a function that takes a value that is returned from another function. It happens. It happens in programming. Okay. And I'm sure, I'm certain that task should find a way and let you do that thing where a value that is returned from a function is used in another function. So in order for that value to be used in another function, that value need to like a value should be returned from that function, right? A value should be returned from that function. The Satchom, your hand is up. Jump.
Yeah, you're talking about the fact a function can get another function. I wanted you to just show an example of that. You can please. What you
Okay.
just said last. Yes, thank you, sir.
All right. So there are situations where let's assume that I have another function, right? Probably I have another function that says a function that could be I don't know, maybe let's say something that age multiplier, right? Age multiplier. Does that make sense? Let's use this age multiplier, and then basically this man takes in a value. So therefore, this value we can call it a or anything. We can call it probably a multiplier. Okay, let us call it multiplier. Let us call it this value multiplier, right? So and then I basically want to get that multiplier and say, okay, probably multiplier and then h. Okay, let's say it takes in two things. It takes in h and takes in multiplier, right? And then I simply want to say a multiplier or mod should be equals to h times the multiplier, okay? And then probably print. Let's not use return. Let's just say print, okay? But then by default, I would have loved to actually return. Okay, so let's comment on this man as for now, and let's see how that will work. Okay, so basically, this function here is taking age and multiplier. So this multiplier is basically a value that I'm expecting from this function called multiplication, and then age, right? So what I can do is I can come here and say age multiplier, and then I can pass in the age. So in this case, probably the age can be let's say 20, and then the multiplier. So since the multiplier is a function that comes from since the multiplier is a value that I want it to come from this function called multiplication, I simply come here and put multiplication, and then invoke it, and that will happen. And that will happen is that, and what will happen is that once I invoke this function here will invoke this one in turn, and then the value can then be used within what our function itself. So if I run this now, well, that will work as expect. Yes. Okay. So I think okay. We are missing. We are invoking the wrong. Are we invoking the wrong one? Okay. Sorry. This multiplication as well takes in. Remember, this one too takes in two values, right? For the multiplication. So I can put probably I'll put 10 and 10. Okay. And then fire it up and see it works. So it can only what happened is that this function here fired, right? And then the result was returned. So that means we got the actual value. Something came out from that function. And then that thing is now passed to this other function alongside what with 20. And then what this function now went ahead and do what and execute itself. That's basically that, right? So what I can do is that Mr. Gabriel only use return to send out something from a function. Does that make sense? Okay, just know that. Okay.
Can I ask something? Can I ask something? Can we take only one value from def 1 and add in and multiply it with one value in def 2?
Right, so I think I'm kind of confused now. Can I take one value from, let's say, multiplication, right?
Yes.
And add it to a value in new age, in age multiplication?
Yes.
Okay, so I think I'm lost. Right. So okay, so let me try and understand you properly. Okay, so can I? Oh God, it's confusing. Okay, so can I get Sorry, please ask the question again, please. Sorry, let me.
When you ran the first code, you said,
Okay.
"Oh, this is supposed to get two values." You now
Oh,
added that second. I'm asking,
okay.
can we take only one value instead of the second value?
Instead of two. Okay, like this.
Yeah.
Okay, so no, we cannot. So this function is also a function that has two parameters. So it means that wherever you are invoking it, whether inside a function or outside a function or for a variable, wherever as far as you invoke that function, you must provide what two arguments, because by definition, this man takes in two parameters, right? That is why. So we can't. So even if I try this now, I'll say that this determines that this man takes two, but one was given. So he says that what missing one required positional argument num two, right? So one is given, but it takes two, but only one was given, right? So a function that has two will always take two. A function that has three will always take three, wherever it's being invoked, whether inside a function or outside a function, or given as a function argument, or given as a value to a variable. However, right, that function must has its own value. Okay. So user, your hand is up again. Is that understood, please, Mr. Gabriel?
Yes, sir.
All right. So, user, your hand is up again. User.
So what you are saying is that in this, excuse me,
Okay.
can you hear me, sir?
Yeah, I can hear you.
What you are saying is that now when you called this function age mod, that means
Okay.
this function multiplication is now
Okay.
acting as like call it
Argument.
how do I put it? That's acting as an argument
Yes.
when you call the function age mod.
Yes, exactly. It's acting as argument. So basically, it means go and invoke this other function and use that value as the second argument there. So it's acting as the second argument.
Okay.
Right. So this is also similar to us doing this, right? It's also similar to us doing this. So I can cut this, right, and put it here and call this b equals to this, and then just carry the b and put it. You see the same thing, right? Because if truly this man is sending out a value, then basically that value is saved to this variable, right? So I can just carry that variable and put there, and it's the same thing. Or I can just carry the whole function and just put it there, and it will still work. Is that understood?
I still have a question to ask.
Okay.
Can we assign a function to multiple variables?
Yes.
Like as you assigned b to multiplication here, can you still assign, let's say, a to that same multiplication?
Yes, of course. Yes. That's the whole point of function, to reuse the code over and over again. So I can have a equals to multiplication. And the good thing is that since it's a function that takes parameters, I can have separate parameters. So I can have like 20 and 30 here, right? And it works. It's a separate parameter for b. That's the beauty of function. Does that make sense? Okay, Mary Jane, your hand is up.
Okay, so my question, can you hear me?
Yeah, I can hear you.
Okay, my question is like, now if you have a large code now and you have
Okay.
probably defined a function up and you can't remember like the name you gave it and like the number of parameters you gave it, how are you going to, is there a way that you can list out the functions that you have in your code base or something?
Is there a way we can list out all the functions we have in our code base? Can't think of a way right now. Except you have to logically write some code. But I'm not sure there is a way you can list out all the, assuming you have a large code base, I have like multiple files. Not too
Yes.
not certain. I'm not certain that there's a way. But then what you can do is that if there's a way you can remember your if you can remember your function name, then to know how many arguments that function takes is something that you can solve, right? But I don't think there's a way that you can list out all your available functions. Not sure.
Okay, thank you.
Except okay. Yeah. I think there's a way. Okay. So except okay, but then that way that we need to arrive at model because to understand it better, it works in if you are discussing models. There's a way, yes. There's a way that you can list out all your functions. Right. So but then when we will put that question on pending, when we get to models, please bring it back up, then I'll show us how you can list that out. All right, so Miss, so someone, I can't find your name. If your hand is up, please go ahead and unmute and ask the question, please.
Okay. It's still based on the questions we asked. Is
Okay.
there a way I can just write all my functions in another file entirely instead how they do this HTML CSS stuff? I put all my functions on a different file so that when I want to search for it, I can just go to that file and then I think look for a keyword to search for all of my functions. Is there a way to do it like that so that there will be like a link, like there will be a link between these files? I don't know if you really get me.
Yeah, I get the question. Yes, there is a way. There is 100% the 100% possibility of doing that, but that also falls inside models. So please, when we get to models, we'll come back and answer that. But there is a way. Yes, you can have multiple files interact with one another, right? So that's basically what people do, right? So no one writes a large code of base in one file. It's not possible, right? Well, it's possible, but then it look messy, right? So but then you can split it and put it in separate files like this, and then each of them can interact together, right? So there's a way, but then we have to paint that question until we get to model, right? You have to get that question when we get to model. All right. So to conclude with return statements for Mr. Gabriel, okay, and whoever else is having a difficulty, right? So basically, what I want you to note is that function body is local to the function, right? So basically, what that means is that everything that happens within that function, everything that happens within that function will stay within that function. It means that nothing is leaving that function by default, right? By default, function body is what is local to that function, right? So it means that everything that happens within that function will also do what stay within that function. But if there is need, okay, to send out information from a function, so we use the return statement. So basically, so let me rephrase this. So function body is by default. Okay, let me put by default there. So you know that it's by default though. By default, function body is local to a function. So everything that happens within that function, okay, will stay within that function, right? But if there's need to set out information from a function, then we use return statement in this manner. So the manner is that you put the return followed by value to be sent out. So let me put it down here. Right. So that's basically what it is, right? So and you put the return keyword followed by the value to be sent out, right? So in that case, only value. So in this case, comma, only value to be sent out can leave the function and can be accessed, can leave the function and can leave the function. Right. So Mr. Gabriel, does that make a lot of sense? Does this not help?
Yes, sir. Thank you so much.
Right. So that's basically what will happen by default, right? By default, that what will happen. That everything that happens within a function by default, right, is local to that function. So it means it will live and die in that function. Nothing should leave that function. But then, if there is need to send out information from a function, okay, then we use the return statement. So it means that we only need this return statement only when we desire to do what, to send out information from a function due to this default behavior, right? So now, but if this is the case, right? If it's the case, then that means that only this value, right? It can leave the function. So this is sense, please. So it means that only this value is what is leaving that function, right? Every other thing still remains in that function. But if there is need to send out more than one value, of course, you can do this, right? So for additional sake, right? If there is need to send out more than one value, then you simply separate them with commas, right? And then you can send out another value. Probably you can send out another value, right? And so on and so forth. So if you need as many values, then you can separate them with commas, right? And send them out all at once, right? But then these are the only things that will leave this function. Apart from that, everything will live and die in that function, right? So, but if you have more than one thing that is leaving the function at once, then in that case, you need to do what, also provide three variables that will match what those three things that are living. So in this case, I have like A, I should probably have like something like A, comma B, comma C, right? Where A is for the first value that is living, right? B is for the second one, C is for the third one, and so on and so forth. Now this thing here is called decoupling, right? It's decoupling. So you are basically it's more like unboxing, right? So it means that whatever is coming out as a box, and then we simply unbox it and say that what the first one should be for the first variable, the second one should be for the second one, and the third one should be for the third one, right? But if there's only one, then just put only one variable. If there is more than one, of course, you use the appropriate number of variables for that. Question put it into functions. So we can touch down.
This explanation, I'm confused. This last explanation.
Sorry? Okay.
This last explanation.
Okay, we need another one. All right. So okay. So basically, what I'm saying is that from this note here, it says that only one thing can live at a time, right? But then I'm also saying that if there is need where you need to send out three things, right? Three things like this. Okay. Like let's say the result, you send out another string called another value, and then you send out what 30. So these are the three things that will leave this function, right? Because of what? Because of the return statement. Okay. So now if I should assign just one, let's assign just one variable called A, and then let me print out A, right? Let me print out A. So we see what is coming out. So you think what is coming out there is coming out as a tuple. So I'll comment on this. Okay, I'll leave it there. I'll run this now, and then you see what we have. You see, it's coming out as a tuple, right? So when you return more than one value, it comes as a tuple. And then
Sorry, network is bad. I cannot hear you.
Can you guys hear me now? Please confirm that you guys can hear me. Please.
Yeah, we can hear you.
Yeah, we can hear you.
All right. Okay. So I'm saying that of course that you can return more than one thing at a time. Okay. So the return statement doesn't necessarily mean that you can only return one thing at a time. You can return multiple things. So you simply need to separate them by commas, like what I just did here, right? What I just did here. So I return the first thing alongside with another thing alongside what with 30. That is three things. Now, if you have this kind of return statement, what is coming out as a tuple. Remember, tuple are what? A collection of items separated by commas, including what in parentheses. So if I print this now, this is what I'm having as the result of that function. So it means that after this function has finished executing, this is the result that was sent out, right? And then of course you can still access this item as a number tuple. I can still come here and do this. I can still come here and do it and say, okay, I can still come here and say print, and then I use indexing and say print the first item, right? And I'll get 100 at the first item, right? And then I can do the second one, and I'll get the second item, Abi? And then the third one. And I can get the second one rather, and then I'll get the third item, Abi? That's what we did now in our previous class. Now what I'm just doing here is more like a trick, a tip and trick kind of, right? I'm saying that you can just do A, comma B, comma C, and then this value we do what we simply just decouple, right? And then assign each of them to A, B, and C. So that means I don't even have to come and be indexing it like this. I can just simply just come here and say print A, and then repeat this for B and C. And each of them will do what will have their own separate value without necessarily without me necessarily coming to do what to actually get it by index. Okay, so this thing here is decoupling. You can call it decoupling. So you just decouple it and then give it to each of the variable there, right? And then if I run this now, so you can say I have my 3 values assigned to each of those variables. Okay, that's basically what I'm doing there. So this is more like a tip and trick kind of, right? So it saves you the stress of going to go and accessing it one by one, right? By using index. Are we together?
Yeah,
Does that make sense?
thank you.
All right. Any other question? Any other question? Okay, so that is basically that about function, but we have to touch down error handling, even if it's 10 minutes, because there's nothing really much about error handling. It's a very simple concept because we need to actually apply it in that task, right? And can we move to another function? Okay. Yeah. We are wrapping up. We are wrapping up real quick. Okay. So one more thing again that I should know is that the return statement marks the end of your function. So it means that if I have another code after this man, right? So by default step, you can say that the moment I click on enter, it takes me out of the function, right? It means that that function has end. That's where it's ending. So whenever Python comes across the return statement in a function, it means that that function has ended. As such, this value should be what should be sent out. So even if I have even if I try to bring in this print, let's just bring this print after the return statement, then you say that nothing will happen. The print there will never execute. That print there will never execute. So if I run this now, you can see that print will never execute in this life. So you can see the print did not really show, right? We will not get that print. Let's put something like something more readable after return statement. So you run this now. See that print never showed, right? So please note that what you only want to use the return when to mark the end of your function, right? So the return statement marks the end of your function, right? So where you place it also matters. So if you have conditionals inside your function, where you place your return also matters, right? So that you don't end up terminating your function before it even finish what it's supposed to do, right? So please use it wisely as well, right? Use it wisely as well. So that's basically that about function. Question before we touch down error handling. Question. All right, so silence means no question. So let's look at error handling real quick. Excuse me. Okay, let's look at error handling real quick. All right, so error handling is more like there are situations where we have so I want to copy this code and so that we can quickly just wrap it up. There are situations where there are situations where we have code, right, that are syntactically correct. So what do I mean? This code is correct syntactically, right? But then it causes a problem during execution, right? So basically something like this. Like let's say if I have result equals to num1 divided by num2, right? And then I just say print result. All right, so if you look at this code is correct, but syntax wise, right? That code there is correct syntax. If I run this code will execute just fine. Abi, if I should enter the code and then I say I enter 20 and then I enter 2, I will have 10.0, right? Then it means the code is working fine. There's nothing wrong with this code. But then we have this kind of errors that we refer to them as exceptions, right? Exceptions, right? So there are errors occur during program execution, right? So it means that this particular error does not even occur during exception during the, it means that what that this error does not even happen during compiling states. It means that the program has compiled properly and it's now running. Abi? But then over time, something happens during the execution and it terminates, right? And those are the kind of error that we can handle in Python, right? And they are known as exceptions, right? They are known as exceptions. So I run this code again. I run this code one more time so that you can see it's running just fine. But I can tell you that something can happen in that code and this thing will break, this thing will crash, right? During execution, right? So one of them is that one of it is this, right? So if I should run this code and then probably I have something like hello, right? See it happen, it crashes the code, right? So yeah, so those are the things that can do what cause our program to do what to stop abruptly, right? So it's probably someone entered a wrong value, right? A wrong value. The weapon it throws an error like this. So this error is caused during what trying to do what typecast that string to integer. So you cannot. Another problem again another thing again that can cause this problem again is something like this, right? So if I run this code again and then I have something like 10, and then I have something like 0. See, another problem. It says that you're trying to do what to carry out a division by 0, and by default that is an error in math. You can't divide by 0, right? So those are the things that can cause what exception. And how do we handle this kind of thing? Because once an exception happens, right, it terminates your code. So even if you had other existing code, like let's say I come here and have another code here saying exist other codes, right? And I have another one that says another code, right? But then the moment I have exception, the code doesn't even get to the down part. You see? So it means that if this was a larger program, it means that a small portion can stop the entire software from working. You see, and we don't want that. We do not want that. We don't want that kind of situation to do to always be our case. So what we can do, we can handle this kind of situation, errors that occurs during execution, and to handle this, we use a keyword in Python, two major keywords in Python, and they try and accept. They try and accept. So these are the two keywords that we use in handling exceptions in Python, right? So they try and accept is similar to if and else them, right? But then they try, unlike conditional where if can exist on its own, they try cannot exist without without the except, right? So if there is try, there must be an exception, right? And then in Python we have different types of exception. We have different possible errors, right? We have different. I will list few of them, right? I will list few of them, few exceptions that can likely happen during your code execution. So one of them is that one of the the one that we've just seen right now is 0 by division exception, right? We have 0 by 0 by division error, right? And then we have another one. We have value error, the one that we just did, where we try to do to typecast. So this was the error that showed. So every exception, right? Every exception is always shown in the console, right? So if you're not sure of what kind of error you are planning to have, right? You can get them in the console. So if I run this code again and then I try like 2, right? This is the exception name there, value error, right? So this is what is, or should I say, this is the cause of this particular crash. So if I should have another kind of error, another kind of exception, let's say 10. Oh, sorry, not there. Let's say I have 10 and I have 0. Oh, sorry, 10 and I have 0. I have another error. And this one is called 0 division error. So there are many built-in errors. There are many built-in errors that we have in Python, and I think there are about 15 of them, right? But these are the few of them. We have name error again. So someone just listed name error in the comment, right? So name error is when we are trying to get a variable that does not actually do what exist, right? So we have syntax error. Syntax error is not really an exception, because if you have syntax error, they mean that the code will never even compile, right? But exception is that the code has compiled, but then it broke during execution, right? So syntax error doesn't really come in there, but then it's also a type of error, no doubt, right? But then I won't really place it inside exceptions, right? I won't really place inside exceptions. So I will leave that one to us, that you can go back and research the other kinds of exceptions. But then let's manage what these possible errors that we are having, right? Which is what the zero and value error. So how do we manage these things? We try and accept. So the way try and accept works is that you have what a try. So a try is, from the name itself, it means what? Try, like try this one out, right? So basically, is the part try takes that your specific portion of code that you feel, you as the developer feel that this portion might likely cause problem. So me as developer, I can clearly see that these 3 lines might likely give me issue, right? If a user should type a wrong number, that my code will crash. If a user should also type 0 as num2, that my code will also crash. So me as developer, I've seen it already. So what do? I simply put that one there as in the try block, right? So I'll tap it in and put it as the try block, right? I'll put it as the try block. Now remember, I said what, as far as there is try, there must be an except. So then they coexist, right? So unlike conditional where if can leave alone without the elif and else, this one try must leave. You can't have try without except, and you can also have except without try, right? Two of them must exist. As far as there is try, they must be except. All right. So now the try takes in your portion of code that may cause error. So let me put it down here. So try, right? Try takes in portion of code that you as the developer feel it might cause problem during execution, right? So that portion of code that goes the way to try. So me, I've seen mine that this man here will likely give me problem, right? Either num1 or num2, or this result of trying to do to carry out this division. So I put it there, and then the except now takes the portion of code except. This one takes the portion of code that should execute if there is problem. Right? So now that's what the except does. So it takes the portion of code if there is problem. So basically I'm not saying what the except comes in here, right? So the except comes in after a try, and then inside this except it takes the portion of code that should execute if there is problem. So the syntax is this, right? The syntax is basically this try, right? I'm trying to be quick as fast as I can. Sorry. So here takes in here. So this part takes in code that might cause problem during execution. Please forgive every type of error. I'm trying to be quick. And then it takes what? And then we have the except. This except typically takes the exception type, right? The exception type, optional exception type, rather, I would say. Optional exception type. So it's optional. You can put it. You can choose not to put it, but I'll tell you why you should put it and why or when not to put it. All right. So you have optional exception type, right? And then code here is going to be code to execute when there is problem, right? So you can have multiple exceptions, right? But you can only have one try. You can have one try, but then you can have multiple exceptions, and then you can have and you can have optional exception type. So you can choose to specify which exception are you trying to target, or you can choose to leave it blank, right? But I'll leave it blank for now. I'll come back to it, and then here I would say print problem with code, right? For now, problem with code. I'll just put problem with code. And I basically want to now say, okay, let my result now. At this point, I'll set my result to be what, to be 0, because remember, outside my try and except, I have what, I have where it says what print result. So it means that if any of them should cause problem, that will not have a variable called result, right? So here I'm trying to say what I'm trying to set that result to be what, to be 0. So even if there is problem, we still have, I still have to set what, set result to be 0, so that outside here we can use it down there, right? If not here too, we also have another problem. Okay. So if I should now look at that, okay, so we are done. Let's run the code. Right, so if I run the code now, and then I cause a problem. You see, it's still, the problem was managed by saying what problem with code, but then it still went ahead and do what, and execute the rest of our code, right? So it did not just stop abruptly, right? So that is how you can manage it. But then the problem here is that this exception now is now showing for all the possible error, right? So probably, let's say I want to show problem with user input, right? With user input, right? And then I run again, problem with user input. And then if I have problem with user input, let's say I tap into, of course, it should be, of course, I have the appropriate message showing what problem with user input. And of course, our code did not also stop. It went ahead to do what, to handle it and do what, proceed with the rest of our instruction, right? Exactly. So, but then if I also come again and run again, right? And then this time around, the problem is not from user entry, right? Probably this user has entered a correct valid integer values, right? But then the problem now is now coming from, okay, sorry, let me cause another problem. Okay, so probably these users have entered a valid integer, right? But then this other problem now is now coming from where? From division. But we are still having what? Problem from user input. So that's the problem of what? Of using the except without specifying the kind of what exception. So this except here does what? Catches all the exception, right? So if you don't specify the exception, it catches all of them, right? And that wouldn't really be okay, right? In this case, because we have what this code here in the chair, we have two possible kind of what problem or exception, which is what the valid error and the zero division what error. So using except, right, to catch both of them doesn't really give the appropriate message. So in that case, I can do what? I can now come here and then explicitly now say this one here should do what should be for value error, right? And then I can do the same thing again for what? For division what? By zero error, right? Division, zero division error, rather. And then I can now pass the appropriate message, problem with what? With division. So this way I can now know, okay, that find that is problem with what? With division. So this one, it makes more sense. And then if possible, I can still come here and do what? And put the another except that should do what? That should catch everything, right? So this one here should come last, right? So if you have explicit ones, this one should come first, and then this one here can come last. So just in case we have another kind of error here that we cannot see at the moment, right? Because at the moment we are only seeing these two, valid error and what? And zero division error. We never can tell. If it was like a broader scope, a broader software or program, you can never really see all the errors completely, right? So to avoid any unforeseen circumstances, right, I can simply add this one, right, to catch another one that's outside these two. Okay, so in that case, I can simply come here and then I can just say problem with code. Because at that point, it's not from the user input or division. Probably there's something somewhere else, right? So I can just simply say problem with the code, and then I can still set my result to 0. Remember, because I need this man to still work down there. Okay, so if I should now run this again, and then I cause problem with user input, I have the appropriate handling saying what problem with user input. If I should now have problem with division, with division, I say 10 and 0, and I have what problem with division, right? So you can see that the exception now catches for each specific error type. Are we making sense? The exception now catches for each specific error type. But then if we now have another kind of problem outside this man here, and then at that point, this man can know what can handle that problem. Probably if I try to do something like this, let's say print. Let me print something that does not actually exist. Or probably I have a variable here called a is equals to 10, and then I mistakenly do like a equals to this, right? At that point, I cannot really tell, right? I cannot really see that this should be an error, right? So that is where that is where this man can now fire up, right? So if I should now run this now, I now have what? I now have my 10, and probably I can have my appropriate, like like everything works fine, right? But then I have problem with code because we have this man trying to do what, trying to print a variable that I mistakenly do uppercase instead of what, instead of lowercase. So at that point, this other exception does what, fire up, right? Because this one here, because this last one here does what, accepts all errors, all errors. Okay, question, 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 question.
Hello, sir.
Right, so no question. Right, so that's basically how we
Hello, can
can.
you hear me?
Okay, yeah, I can hear you now.
So I want to ask, so now that we put that our question inside the try block, we don't need to repeat it outside it.
Now that we've done what exactly, please?
The num1 equals to int that our block input
Okay, here.
number, yes. And so we don't need to write it outside again. Once we've already put it in the try block, we don't need to write it outside.
No, you don't. You don't need to write it outside, right? So it will just stay there, right? The
Okay.
try block is more like it's not necessarily like it's more like a conditional, right? So we're just saying try this man first. I try this block of code, right? If there's any problem, then find solution down here. That's basically what it means. So if there's any problem, find solution from any of these three exceptions, right? And then handle it. So your expressions can be long, right? Your expression can be a long code that actually handles this situation appropriately, right? It doesn't need to be just something like this, right? But it can be a very long code that handles this problem very well if it was like a larger application, right? So you don't have to write this again outside, right? You don't have to. So you stay there one time. Is that understood?
Yes, sir. Thank you.
Right. User, your hand is up. Yes, you can use if and else. You can use if and else. Basically, still like I said, that all this concept is meant to be used together. All concept is meant to be used together. So I can have my if inside here and do my conditionals, right? If there is need for it, right? It will still work. So this concept, just know that each of these concepts are meant to be used together. You can use if and else if inside your exceptions, right? So, but these are the two keywords. But then we have another keyword that we use in handling. Finally, it's not really being used, right? Finally and else. There's also else, but I'll leave that one as take-home task, right? Not for grading. You can check out how finally and else work, right? So finally and else can also be used in conjunction with try and except. So you guys can check it out how those two works with try and else and try and except, right? You guys can look that one up on your spare time, right? Any other question? But then within this block, we can use our our standard conditionals, right? Our if, elif, and else is within this try block, within try and except, and even within the final and else as well, we can still use them, right? Question, Mr. Samuel, your hand is up.
Yes, sir. Can you hear me, sir?
Yeah, I can hear you now.
Okay, I don't know if other people's hands are up. I would like to talk last.
Okay, let's see if other people's hands are up. All right. All right, Mr. User, you get it up. So the Samuel said that you come up first and he comes last. So user, please unmute and ask. Let's wrap it up. User, please. At times it's better that we just set our Zoom name to our actual name so that we can actually call ourselves by our actual name, right? So this user is more like a generic name. So probably in your spare time you can just edit it, right? So that it shows like my name here and Mr. Samuel's name there, right? And the rest of our names, right? Okay, Mr. User, your hand is up. Do you have a question? Right, so user's hand is down. Okay, Samuel, please come up. You are the only one with your hand up. Mr. Samuel, you're the only one with your hand up. Mr. Samuel. Right, so Mr. Samuel's hand is also down. So I will assume there is no more question. Right. Okay, so please, that is basically that about functions and error handling. And we've basically I love the energy, right? I love the energy that you guys are putting in. And shout out to those guys on your group that is keeping that group active, bringing in questions and solutions and stuff like that. I see you guys, right? I see the effort. I see the effort, including those of us that are also participating in all these activities. People are doing wonderful, wonderful works, right? So, but then as I'm moving forward, we are doing what we are growing, right? We are growing, we are learning new things. So please don't just learn and abandon the previous ones. Remember, we are adding to what we've already known, right? We simply just compound and then we will get there, right? So remember, progress over perfection. I will say it over and over, the progress over perfection, right? So keep moving. You don't have to be 100% perfect. Just keep moving, right? And then please do your tasks on time. Submit your tasks before time. In a previous task, I've seen people that did previous wonderful work, but they can't go above 75 because what they went and submit after the line. But their work was excellent, but I can't do them more than 75, unfortunately. So and then in order for them to even get that 75, they have to actually do extra work by coming out and doing excellent work, right? So if you miss deadline, it's difficult to hit 75 because you have to do excellent work. All right, Mary Jane, your hand is up.
Okay, so it's not a question though, but it's a suggestion. Can you hear me?
Yeah, I can hear you.
Okay, is it possible for you to be dropping our tasks after we've done it in class?
After we've done it in class, I don't understand.
Like after we've taken some of these concepts now, even in the last task and this one, you added concept that we've not done in class. And most times you have to wait till after class before we start going through it. And now, I missed some part of this class because of network issues. And before they upload the video, it will be towards the night time before I can now rewatch and digest everything that was taught and then now go and try it in the assignment. So is it possible for you to drop the task after classes?
All right, so
Suggestion.
okay, so I will look at that and see how I can work that out because the thing is that your task is supposed to cover whatever you are meant to do for that week. Right? That's basically the standard, right? But let's see if I can come up with something where I could drop because if I can drop a task that will cover something between Thursday and Monday, like Thursday last week and Monday this week. So let's see if that can work. But I'm not saying that is what we will do, right? But I'll take it up with the program manager and see if that will work. If that will work, then that will update us and let us know, right? But apart from that, I will see what I can do, right? I'll see what I can do. Any other question? Any other question? Any other question? All right, so in the absence of any other question, please, we've come to the end of this class and I'll see you guys on Monday. Have a wonderful day ahead. Bye.
Bye bye, sir.